As we saw in the previous video, the runtime execute main, which among other things configures the startup class file. The runtime will call methods configure services and configure inside the startup class. The purpose of configure services method is to configure dependency injection. Dependency injection in classic ASP.NET was optional. In ASP.NET Core, it forms an integral part of the ASP.NET itself. This method adds services to the application to make them available. You get the service collection object that is injected into this method as the parameter. Now you can use this to build on the services that would be available to this application. Example of services could be Entity Framework Core, Identity Services, MVC, and many more. By default, we have the MVC added because of the project that we created. The other method is the configure, and this method configures the HTTP request pipeline of the application. You can see that it accepts an object of another service called iApplicationBuilder, and that object is injected. Also, we have the iHosting environment, which is used to identify what is the root folder and other details, which we'll see as we progress throughout the course. The pipeline specifies how the application should respond to HTTP request. Pipeline is composed of individual parts called middleware, and we will understand that in detail in the next video. But for now, let's take a look at 10,000 image of what happens when a request is made. So here we have a browser, and then we have a pipeline, and then there will be a request and a response back. The individual parts which make up pipeline are called middleware. In our case, we have MVC, and then in the later videos, we would also add authentication to our project. So that would add another middleware. But you should notice here that authentication should be placed before MVC, so that when a request comes in, it is first authenticated and then MVC will come in the picture. We also have to configure middleware for the static files which we have, like JavaScript and CSS. Now when data travels through the pipeline, it gets manipulated by individual middlewares, and so does the response or the result. Now let's take a look at a 10,000 foot image of what happens when a request is made. So the request is made from a browser, and first it arrives at a web server like IIS. IIS would then invoke the .NET at runtime, which would load the CLR and then look for an entry point in your application. It would find that in the main method of the program class and execute it, which starts an internal web server in your application. We will have Kestrel in our application. The main method and the startup class would configure the app, and request would be routed from IIS to Kestrel, and then it would be pushed to application and then processed by all the middlewares and generate the response and route it back to Kestrel, and then it will route it back to the IIS, which will produce the response on the browser. This is much more efficient than the old system.web approach. Classic version relied heavily on system.web, which was tied to IIS. But using pipeline approach, you only plug in what you need, and everything you plug in is a separate assembly exposed in NuGet. Now, since system.web was tied to IIS and IIS is tied to Windows, that is the reason you cannot run classic ASP.NET applications on other web servers than IIS and Windows. Now, since that is no more the case, ASP.NET Core applications can be run on other app servers and operating systems. Now keep in mind there are two web servers. One is the external like IIS, Apache or Linux. There is also an internal web server hosted by your app. Requests from external web server are passed to the internal web server and other way around. You can also choose different internal web server, but the most common is Kestrel, since it has a first-class support in ASP.NET Core. Kestrel is a lightweight web server which can only execute a request, because of which you need external web server to configure other options like security, caching, etc.